All right, guys. So as I said at the beginning, we don't have to agree. I'm sorry. We don't have to just look at a drawing and kind of let our subjectiveness take the best out of us. For example, if we want to look at this drawing, just the drawing, and we want to evaluate the strength of this correlation, I'm thinking this will be a weak correlation, right? Because we can see it from the points. We can just look at it. But there is a way in which we can just look at a number and decide the strength of the correlation. That is called this one. Pearson's product moment correlation coefficient. We call it just R. We want to find the R of this data, all right? The R is going to tell us the strength of the correlation, all right? Now, what is R? R is just a number. The number varies from -1 to 1. That is R, all right? Hopefully you guys are writing this down. R is a number. It goes from -1 to 1. You cannot have a value of R, a Pearson correlation coefficient, of more than 1 or less than -1. No, but you can have a lot of decimal numbers, decimals that are negative or positive. Take a look at this one, for example, here. The R is 0.3. So our Pearson's product coefficient is telling us that this is a weak and positive linear correlation, right? How do you learn that from the value of R? Let me go down a little bit more. Where is that thing? Here. Here is the table where you can take out the values of the correlation. So for example, let's look at this R. Let's just look at the absolute value of R. So ignore, for now, ignore if the value is negative or positive. Ignore it. All right? Just by looking at the absolute value of R, we can see the correlation, the strength of the correlation. So for example, if the value is between 0 and 2.25, 0.25, sorry, 0 and 0.25, we can say the correlation is very, very weak. We almost don't have a correlation because it is very weak. If the correlation is between 0.25 and 0.5, then we say the correlation is weak. Between 0.5 and 0.75, this is a moderate correlation. So now the scatter plot kind of looks like a line. It is a moderate correlation. But if it is between 0.75 and 1, we can say the correlation is strong. All right, guys, these are the values of R. Now, I will teach you how to find the values of R in a second. Or I'm sorry, in a minute. I'm not gonna do it right now. But we can find these values using the calculator. We're gonna jump to that eventually. If you guys like to take notes of this little table. If you like to take pictures, take a picture of this, a screenshot. Go ahead and do it right now, please. This table here is absolutely valuable. Just by looking at the value of R, we can agree on this, on the strength of these correlations, right? Now we don't have to look at the drawings. Now we don't have to look at the drawings no more. We don't care about the drawing. We care about the R. The value of R is gonna tell you what is the correlation. I'm sorry, what is the strength of the correlation, all right? But like I said at the beginning, this is just the absolute value. We are going to ignore the positive or negative, meaning positive or negative is going to tell us something more. Take a look at this. In this case, the value of R is 0.3. So we know we have a weak correlation. But since the value is positive, look, here is positive 0.3. We don't have a negative, so the value is positive. Then we also said the line, the correlation, sorry, is positive. We have a positive weak correlation. Why? Because the value is 0.3 and it is positive. Take a look at this one, the value of R. From the drawing, we kind of see that the lines is kind of going up, right? The points are kind of going up. So we would assume this is a positive correlation, but we wouldn't be for sure until we find the value of R. The value of R here, let me see if I can take out this there. The value of R here is positive and 0.9, meaning, according to our table, this is a strong correlation. And simply because the value is positive, we have a strong positive correlation. Don't forget about linear. We have to say this is a linear correlation as well, because as we saw the last class, sometimes we don't have linear correlations. Sometimes we have exponential correlations or quadratic correlations or any other type of correlation, right? This is a linear correlation simply because of it looks like a line, right? Beautiful. How about this one? R is negative 0.4, 0.6. Just because of the sign, we know this is a negative correlation. Just because of the sign, we know that this is a negative correlation, which means the line kind of goes down, and that is exactly what is happening in the drawing. If we were to do a line here, of course, this is not a strong correlation, right? I would say it is a weak correlation. That's what I would say. I would say this is a weak correlation. Just because of the drawing, it looks like this is going down. So it is negative, right? We have the points are behaving in a decreasing way, going down. So you have negative correlation. But the value is 0.6. Meaning we have, according to our table, if we look at our table, this is a mistake here in the book, I believe. If we look at our table, where is the table? Here. Moderate is from moderate is from 0.5 to 0.75. So it's not a mistake, right? It was 0.6. The value of R, it was 0.6. So we have a moderate correlation, right? Value is 0.6. Again, look at the absolute value. In other words, just the number. And that will tell you the strength. Then look at the sign, and that will tell you the behavior. Is it positive or is it negative? Just like that. All right, guys. So this is R. This is the value of R. This is the value of Pearson's correlation. We have a little bit of who was Pearson here, Carl Pearson. And we're going to see that hopefully the next class, all right? But how did you find this value? How did you find the value of R? Absolutely simple. For that, we have a little bit of a formula. Here are the formulas, all the formulas involved into finding the Pearson's product correlation coefficient. But look at this. In examinations, you will not be expected to use you will only be expected to use technology to find the value of R, meaning we don't have to memorize all of these formulas. We don't. Now, if any of you is going to use this correlation coefficient in the internal assessment, then you do have to use all of these formulas. Because remember, you need to show all the process in your internal assessment, right? In your exploration. But if you're not going to use this in your exploration, then you don't have to use the formula. We can just use technology, which is exactly what I'm going to show you right now with this example. Here we have table 2. And I have here my calculator. Oi. No. Let me see if I can fix this. Oh, no. I can't. Too bad. All right, here. I want to look at the values. I want to increase this a little bit bigger, but I can't. Ah, look at that. Yes, I can. A little bit more. Yes, beautiful. Beautiful. And here was the example. Beautiful. Now we can work. All right, so guys, please try to do what I do in the calculator, all right? So what we want to do first is write all this data in the calculator. And then once we have all the data in the calculator, we are going to tell the calculator to find the product correlation coefficient, all right? How do we do that? Simply let's go to statistics. There. In statistics, as I said, We want to introduce, we want to make it so that this data is inside the calculator. So we want to edit. Press the 1 or enter. From here, you have a list of columns, right? In the list of columns, we're going to write down all the information that we have here. Let's say the mathematics is going to be the list 1. So I'm going to write all the information of mathematics in the list 1. And then biology is going to be list 2. So I'm going to write the information of biology in the list 2. All right? Let's do that right now. 20.
Mister, how do you put that list?
Again, this is the main screen, right? All you do is you press statistics. We want to do a statistic analysis, right? So we press statistics. Now, in this screen, we want to introduce the data. So we press edit. All right, we don't want to calculate. We don't want to do tests so far. We want to edit the information. So press enter. All right, now I can continue filling the information. So 28, 30, 32, 37, 42, and 48. Right? From here, let's move to the second column and introduce the information of the second line. We have biology here. So we can write all that information there. 24, 20, 22, 21, 25. 25, 28, 30, and 32. Beautiful. Double check the information just in case you made a mistake. Always double check your information. Otherwise, you are going to have different values of R. Different values are going to give you different conclusions. So you want to check your information. 20, 25, 28, 30, 32, 37, 42, 48. Beautiful. 24, 20, 22, 21, 25, 28. Look, I said 38 here. It was 30. No, it's 30. Okay. 32. Beautiful. All right. What do we do from here? Now that we have the information, we're going to ask the calculator to perform the analysis. All right. Before I do that, are you guys with me? Can I move to the next step, or do you need more time to write the data?
Yes, good.
Continue.
Okay, cool. All right.
No.
People are saying I can't continue. Does anybody want me to wait? All right, cool. So from here, what do we do now? We press statistics again. Remember, we are doing a statistic test. So we always use the statistic key. From here, we don't want to edit the data. The data is okay. We double check it. We want to calculate things. All right? We want to calculate things. What we want to calculate is a linear regression. This will tell us the values that we need, right? I don't know if this is also in tests. I don't think it is. Give me a second. Let's see if it is in test. No, it's not in test. So okay, I don't know what happened to my calculator. Not working now. Ooh, work, please. Yes.
Linear regression t-test or linear regression t-int. I don't know what is that.
T-I-N-T? T-I-N-T. Man, no idea. Maybe it's a t-test, yes, but it doesn't really matter. If we're doing a linear regression, it should work. But my calculator is not working. Man. All right, let's see if we can cancel it and reopen it again. Sometimes that works. Okay. Please work. Give me a second, guys. I don't know why this is not working. Give me just 1 second, please. There we go. All right. Now let's see if I can reopen it again. I'm gonna have to re-enter the data again. There. Okay, I'm gonna have to re-enter the data. Give me a second, all right? So enter here, edit, and I'm gonna write the data again. 20, 25, 28, 30, 34, 37, 42, 48. The other side, 420, 20, 24, 21, 25, 28, 30, and 32. And I am missing something, man. 4, 20, 22, 21, 25, 28, 30, 32. There we go. All right, so statistics, and then you go here where it says linear regression. Now, if it says linear regression, we are okay. If it says something different, just make sure it says linear regression, all right? The calculator could also be showing something like this, ax plus b, right? Now we have two linear regressions. Look at this, linear regression a plus bx and linear regression ax plus b, right? Which one of these works? Any of them. Both of them work. I like to use the first one because we know lines on a plane behave in this way, ax plus b. A will be the slope and b will be the intersection with the y-axis, right? So I like this one better. From here, we just press enter and we have this information. We're gonna press list 1 for the X list and list 2 for the Y list. Now, in case you introduce this information using different lists, we can always change those names here. Look, the blue on top of the numbers, there is a blue information. Look, L1, L2, L3, L4. We just press second and whatever, and we're gonna change that. So let's say I want to change X list. I can just do second 5. Look at that. Look, now I have list 5 on my X list. Of course, I didn't put it there. I put it in the first one, so I'll just do it again. Now, frequency list. We don't have a frequency list here. We're not gonna write anything there. Stored regression. We could store a regression right now, but we're not gonna do it. We don't want to. We are not looking for that right now. Eventually, I'm gonna teach you how. From here, we just press calculate. It's gonna take a little bit, and then we have our information. The problem is, look, we have the values of A, the values of B. These ones, the ones of our line. So we have the supposedly slope of the line and the supposedly y intersection of the line. But we don't have a value of R, right? There's no R here. We are looking for the Pearson's product moment correlation. For the R, we are looking for the R. And there's no R in here. What do we do? That happens sometimes in some calculators. Now, some of you may have this already activated. So some of you may have been seeing a value of R already. But if this is your case, if you're like me and you don't have this is what you do. We're going to press second and quit, right? From here, we want to, I don't remember what is it. I think it is program. We're gonna press program. No, it's not program. So second quit. What is that thing? Mode. Yes, it's mode. There, beautiful. Again, so we are going to select mode, all right? Inside the mode, we can change a lot of values for our calculator. Here is the point, here is the place where you change, for example, from radians to degrees. Let's say you want your calculator to do calculations with degrees instead of radians. Here's what you do it, right? You can do a lot of things here. But somewhere in here, we are going to find our, here, beautiful, here it is. If you go down, we're gonna have statistic diagnostics, this one, stat diagnostics. In this case, it is turned off. That is why my calculator was not showing a value of R. I want it on. So I simply move to the left, press enter, and then there we go. Again, stat diagnostics. And you enter this screen by pressing the key mode. All right? Simply scroll down until you find statistic diagnostics and hit on. Beautiful. We can go back again. So second mode, so that we can quit and do the process again. Statistics. Now, the data is already edited, so I don't want to edit. I want to calculate some data, right? Some statistics, right? So I'm gonna hit the left bottom to go to calculations, go to number 4 for my linear regression and press enter. All of the information is correctly, and all I do is press calculate. Look at this now. Now I have two values, the value of R squared and the value of R. This one is the one we wanted to find. This is the value of R. This is our product correlation coefficient, our Pearson correlation coefficient. All we have to do is write it down somewhere. And there we go. If this was a quiz, all you have to do is write this number down. If this was an examination for the IB, the real examination, the one you guys are going to take when you are in 11th grade in November, you just write this down. That is it. It's that easy. That is how we find the value of R. All right? Let's try to answer this question using this value. So here it says, the first question was plot the data points on a set of axes. We can do that here in the calculator. I'll show you in a second. Comment on any correlation you can see on the graph. Man, we're going to have to do it right away, right? Then find Pearson's product moment correlation coefficient. Oof, find the R for this data and comment on it. All right, so what do we can say about this? What can we say about this? About the R? Okay, so we have a table, right? The value of R is 0.86, almost 0.9, almost. So this is clearly a strong correlation, simply because of our table. Just by looking at the value of R, this is a strong correlation. But is it positive or is it negative? In other words, are the points going up or going down? To know that, we just have to look at the sign of the value of R. Okay, the value of R is positive. This is 0.8. This is a positive number. So this is a positive, strong, linear correlation. And that is it. All right, this is how we read the information of the R. Okay? Beautiful. Now, how do we plot this just in the calculator? In case you didn't know, just in case you didn't know, we can go to graph. I think it was graph. No, it wasn't. Maybe trace. Second statistics. Man, I know. I knew how to do this. I knew how to do this. And I don't remember now. Ah, here, statistic plot. There we go. Statistic plot. There we go. So if we press second and then y equal, second and y equal, we're going to have statistic plot, right? From here, we can find the type of plot we want, right? So if we just set plot 1, we're going to have this one, right? What is the type of plot? We want it to be on. We want to plot these ones. And we want this type of plot. Each and every one of these are types of plots that we have seen. Right? So far, it's in the first one. This one is a scatter diagram, and that is exactly what we're doing. We want a lot of points in the plane. That is a scatter plot. right? We don't want it joined by lines, so we don't want the second one. We don't want a bar graph. We don't want any of these box and whiskers. We don't want any of these. We just want the scatter plot, right? X list, list 1, Y list, list 2, mark in color, that doesn't really matter. And from here, you just press enter, right? From here, now that everything is correct, we can go back a little bit. And now we can plot it. I believe it was in graph. No, maybe trace. Man, I don't remember how. In trace. 20 with 24. Yes, the data is right there, but I cannot see it. Oh, right. Maybe I cannot see the data simply because of the window, right? So if we change the window for some values that let us see the data, then maybe that will change. For example, in X, we want from 20 to 48, maybe. So let me change that to from 0 to what? To 50, maybe. From 0 to 50 with a scale of 1. There we go. And in Y, we want it from 24. Look, no, from 20. This is the lowest one, right? From 20 to 32, maybe. So let's just say from 0 to 40 with a scale of 1. Now we can trace the data. And look at that. Now we have our scatter plot. Just from here, just by looking at this, that was the question 1, right? Plot the data. For question 2, comment on any correlation you can see on the graph. Just by looking at the graph, guys, just by looking at the graph. In this point, we haven't really used the R. Just by looking at the graph, we can tell if this is a strong, a weak, or a moderate correlation. Now, the points are really close to each other. So this is a strong correlation, right? And the points are going up. They behave in an increasing way. So this is a positive correlation, right? Which we can verify by finding the value of R. So that is exactly, those are the steps you take. First, you plot, then you look at it, and then you verify using Pearson's coefficient. All right? Beautiful. Let's stop the class right here and give you guys some time to practice.